Hello, welcome to the video instructions for Module 15 of our course. This module will be focusing on linear regression, which is chapter 13 of your OER. Please remember to be checking in regularly to your Canvas so that you can complete the assignments for this module by the due dates. Those assignments are going to include your discussion board, video response, and quiz, all on linear regression. And if you have any questions or concerns, please feel free to reach out to me. Also, as usual, there is a PowerPoint that I've created along with a summary for the chapter. Be sure to use your OER chapter, the summary, and the PowerPoints to have a better understanding of linear regression. This is somewhat of a short chapter, and we're just going to touch the very surface of linear regression, which actually builds off of correlational analysis that we saw in our previous chapter. If you remember, we were looking at the relation between two variables for correlation, and we were describing that relation in terms of it being a linear regression. We were also describing it in terms of the strength of the linear relationship and the direction, meaning is the correlation positive or negative? Does one variable increase while the other increases, or does one variable decrease while the other increases? Remember, this is related back to algebra and pre-algebra in terms of examining a line, considering the x and y axes. In the previous chapter, we just looked at the relation between the two variables. Now, for linear regression, we're going to actually be testing the slope of that line, and we're going to be using that slope to predict values for a future relation that is also on that same XY scatter plot. As usual, we need to start by examining the scatter plot, and then as we use the variances of the correlation, we'll be able to make a statement about a null and an alternative hypothesis and then test that. Similar to ANOVA, regression is going to use the F statistic, and it's going to be based on a critical value from the F table. This introduction to linear regression is going to allow us to relate two variables to each other and use that for prediction in the future. More advanced regressions called multilinear and multivariate regressions can use more than two variables in predicting the regression line. The regression line is going to be the equation that best suits the data, and it's the same type of relation we explored in correlation. Now also, there's a direct link between ANOVA and regression. As a matter of fact, we're going to use the ANOVA table as we're calculating regression. We'll be covering ANOVA and regression in our computer lab. Again, I don't want you to worry about calculations because we have statistical programs that do that for us. What I want you to focus on is our ability to use a line or a regression line to predict a relation that we don't have data for. So correlation and regression are both based on sample data that we're going to use and test to be able to predict what a person would potentially score if we don't necessarily have that information. Okay, if you have any questions, go ahead and reach out to me. Other than that, I will see you back in the final module for this course, which is Module 16.